On this lesson, we will go over the basics of using the JF-17 radar. Due to the complexity of the subject, on this lesson we will focus on the BVR modes of the air-to-air radar. On future lessons, we will examine the close air combat modes and the air-to-ground radar modes. Press spacebar to begin. The JF-17 autopilot is active, so that you can take a moment to set up the cockpit. We have also placed DCS on active pause, while we configure the aircraft and explain the radar basics. You can adjust the cockpit lighting, if needed, using the knobs at the right console. Press spacebar to continue. As we want to practice the radar use on air-to-air combat, please select air-to-air master mode using the T1 switch on your HOTAS, or press the key number 2. Good. Air-to-air mode is now selected, and the mission computer has assigned a default configuration for the MFCD displays. Press spacebar to continue. MFCD setup. We will now customize the MFCD displays to our taste. The aircraft's computer will remember our layout, even if we change to another master mode. When we return to air-to-air, the displays will still be as we left them. First, let's change the right MFCD to show the radar page. Click on the MFCD menu button. Next, click on the radar button. Perfect, the radar page is now selected on the right MFCD. Press spacebar to continue. Next, let's change the left MFCD to display the HSD page. Our intention is to have a better view of the radar in HSD by placing them closer to the HUD. Click on its menu button. Next, click on the HSD button. Good, the HSD page is now displayed on the left MFCD. Press spacebar to continue. Finally, let's change the center MFCD to display the SMS page. Click on its SMS button. OK, the SMS page is now displayed on the center MFCD. All three displays are now customized to our preference, for the air-to-air mode. Press spacebar to continue. You can check the customization by briefly changing the master mode to nav or air-to-ground, and then return to air-to-air. The MFCD should be as we left them. From this point on, please don't change these MFCD page assignments, as this mission's trigger logic relies on them. Press spacebar to continue. Radar modes. The JF-17's radar has 3 modes for BVR air-to-air use. RWS, range while scan. TWS, track while scan. VS, velocity search. You can tell which mode we currently are by looking at the highlighted field on the radar MFCD. The mode is also shown on the HUD, next to INTC, intercept mode. In order to manipulate the radar using the HOTAS, please make the right MFCD sensor of interest, SOI, by pressing S1 right. Now that the radar MFCD is SOI, we can cycle trop the BVR modes using the HOTAS, pressing on S2 left. Currently, we are on the default TWS mode, but we will describe first the RWS mode. Please press S2 left to cycle the radar modes until RWS is selected. RWS, range while scan, mode. This mode provides all aspect detection of targets and is used on the initial phase of air combat, when the target is at greater than 10 nautical miles. The display shows range on the vertical axis and azimuth angle on the horizontal. You can adjust the display range scale using the buttons next to the highlighted value. It can be set to 10, 20, 40 or 80 nautical miles. The maximum detection range is around 55 nautical miles, and in this mode it can maintain track files on up to 10 contacts. We will now review the main elements of the RWS display. Press spacebar to continue. Radar cursor, also called TDC, target designator controller. After the throttle switch that controls its movement, switch T5. The 2 numbers to its right display the maximum and minimum altitude, in thousands of feet, of the radar detection cone at the current cursor location. Note that, as you move the radar cursor up and down, farther and nearer to your aircraft's nose, these altitude values change. A negative altitude number means that the radar detection cone is colliding with the ground. In this case, move the radar elevation up a bit, so as not to waste its area by scanning below ground. They reflect that the radar detection cone gets bigger at greater distances, and narrower at closer ones. On the briefing there is a diagram illustrating this effect. Note that if you move the cursor over the top limit, the display scale will increase. If you move the cursor below the bottom limit, the display scale will decrease. Press spacebar to continue. Radar azimuth. The azimuth is, basically, the horizontal angle of the radar detection cone that originates from the radar antenna. The highlighted button cycles between the different azimuth settings of the radar. The azimuth values are in digress and are for each half of the cone. So, a value of 30 corresponds to a total detection cone angle of 30 degrees left plus 30 degrees right of the aircraft's nose, for a total of 60 degrees. You can also cycle the azimuth values using the HOTAS sensor control S2 right. For this lesson, please set it to 30. Press spacebar to continue. The highlighted symbol is the azimuth caret, that shows how the antenna scans the azimuth range from left to right and then right to left. Use the HOTAS S2 right to cycle through the azimuth values, and note how much longer the wider values require for the scanning. This is why we will use wider azimuths while we search for contacts, but switch on to narrower azimuths once a contact has been found. For this lesson, please, leave the azimuth at 30. Press spacebar to continue. When the azimuth is set to 60 degrees, the scan cone covers the whole display, but if set to lower values, like 30, then the azimuth scan zone is narrower than the display and is delimited by 2 vertical dashed lines. If you move the radar cursor, using the TDC, T5, HOTAS control, you will note that you can move the scan zone left or right, to make the best use of the reduced zone azimuth. Press spacebar to continue. Radar elevation. On the same way that the azimuth determines the horizontal scan range of the radar, the elevation control allows us to direct the radar detection cone upwards or downwards, to detect contacts that are above or below our own altitude. On the left vertical axis, a scale with the elevation limits of our antenna is shown. You can adjust the elevation with the HOTAS T6 switch. Try it now. Note that the radar changes elevation only at the end of a scan cycle, so it might take a moment for the elevation change to actually take place. Press spacebar to continue. Bar setting. The JF-17 radar has 3 scan patterns, 1 bar, 2 bar and 4 bar, selected with the highlighted button. 1 bar means the antenna makes one full sweep, back and forth, of its detection cone over the azimuth range that we have selected. 2 bar means the antenna shifts slightly upward between sweeps, so that the cone covers a taller zone than the 1 bar setting. 4 bar expand the concept and provides an even taller scan zone. The trade-off is that there is increased time to complete the scan sweep cycle at higher bar settings. On the bottom left corner of the display you can see which bar number is currently being scanned. Press spacebar to continue. PRF, pulse repetition frequency. The radar has 3 PRF settings. High PRF is used to detect targets that are coming toward us, these are called front aspect targets. Medium PRF is used to detect targets that are going away from us, also called rear aspect targets. Auto is a mixed settings, where one radar sweep is done with high PRF and the next is done with mid PRF, on an attempt at detecting targets irrespective of their aspect. The highlight shows the current setting and the button next to it allows us to change it. Press spacebar to continue. Other radar features. We will now review other radar features that you can use. First, on the bottom line is the master arm status. Flick the master arm switch to see the different values that it can display. RDY, master arm switch on. Safe, master arm off. SIM, master arm on training mode. Press spacebar to continue. These items display our own ship flight status. Speed in knots. Heading. Altitude in feet. Press spacebar to continue. The highlighted element displays the position, on the radar field of view, of our next waypoint. There is also an artificial horizon line to help us maintain situation awareness when heads down. You can declutter the radar display, removing both of these items, by clicking on the CNTL button, and on the next menu click on DCLT to declutter. Try it now. Once done, click on CNTL again to return to the main radar menu. Press spacebar to continue. These 2 buttons allow you to place the radar on standby or on silent mode. The slash across them means those modes are not currently on. Standby keeps the radar turned on but reduces emissions to a point that is safe for the ground crew. Silent completely cuts all radar emissions but continues scanning the dish. Use this when you don't want to be detected on RWR. Either option will stop providing a radar picture. We will explain the IFF function on a separate lesson. Press spacebar to continue. 3 targets has been activated in front of your JF-17. Note that the basic contact symbol shows only its current altitude, in thousands of feet. No heading is provided, but the radar shows its previous scans at reduced brightness, creating a shadowy path that helps visualize the contact movement. If you don't see the 3 contacts, be sure to select display range of 80 and either 60 degrees of azimuth or slew the detection con left or right until the 3 contacts appear on the display. Press spacebar once the 3 contacts are visible. SAM, Situational Awareness Mode, Sub-Mode. SAM is a sub-mode of RWS, which you reach by placing the radar cursor over a contact, moving it with the HOTAS T5 switch, and then pressing T5 a single time. This operation is called Bug the Contact. In SAM mode, we get more information about the target, but the radar keeps tracking other contacts. Let's try it. Move the TDC over any one of the contacts, as described previously, and press T5 a single time. Good, we are now in SAM mode. We can see that, upon pressing T5, the contact icon changed onto a triangle, with a short line indicating its heading, and a small number indicating its altitude in thousands of feet. The triangle is enclosed within a circle, to denote that this is an HPT contact, high priority target. Detailed HPT data is shown on the display corner, distance in nautical miles, time to impact, closure speed and target aspect. Please note that the target does not get a lock signal on its RWR. We can unlock the HPT by placing the radar cursor over it and then pressing the switch S2 push or the backspace key. Try it now. Good. By unlocking the contact, we are now back on the basic RWS screen. To continue the practice, select another contact and bug it by pressing T5. Well done, the contact is now an HPT, high priority target. Note that on the HUD the HPT position is marked by a dashed target box, the number inside it being the time to impact, in seconds. A small arrowhead is shown on one of the sides of the target box, to denote. Arrowhead on the left, target is within max range of our weapon. Arrowhead below, target is within no escape range. Arrowhead above, target is outside the no escape range. Arrowhead on the right, target is at minimum range. A large arrow coming out from the target box denotes that the target isn't visible within the HUD and points towards the target real position. Press spacebar to continue. The vertical line that overlaps the HPT icon is the weapon scale. It has 3 green marks, from top to bottom. Weapon maximum range. Weapon no escape zone. Weapon minimum range. These ranges correspond to the currently selected weapon. Note that on the HUD the HPT position is marked by a dashed target box, the number inside it being the time to impact. A small arrow is shown on one of the sides of the target box, to denote. Arrow on the left, target is within max range of on SAM mode. On the center of the radar display you get the ASE, allowable steering error, circle. Near the circle is a white dot, that is the steering dot. The ASE circle and steering dot are also shown on the HUD. To get into a firing position, you have to maneuver the aircraft in such a way that both the steering dot and the target are within the ASE circle. Press spacebar to continue. DTT, Dual Target Track, Sub-Mode. This sub-mode allows you to track 2 different contacts simultaneously. The first one is the HPT that we designated on the SAM sub-mode. If now we designate a second contact, it won't undesignate the previous, but rather will designate it as SPT, Secondary Priority Target. Let's try it. Move the TDC over one of the remaining 2 contacts, and press T5 a single time. Good, we are now in DTT mode, with both an HPT and an SPT targets shown. The symbol of the SPT is the same as the HPT but without a circle. On the HUD only the HPT gets a target box. If we were now to fire 2 missiles, the first would go towards the HPT and the second goes to the SPT. S2 left will switch between the HPT and SPT, try it. Please note that none of these targets will get a lock signal on their RWR. Now, unlock one of the contacts by placing the cursor over it and using S2 press. Okay, we are now back in SAM mode. Now we will see how the single track mode, STT, works. To enter STT, Move the radar cursor over the remaining HPT and press on T5, do it now. It may take a couple of seconds to enter STT mode. Sometimes it is necessary to unlock the contact and then click T5 over it twice, in order to get STT mode on it. STT, Single Target Track, Submode. STT is a submode of RWS, which locks a single target and continuously scans it, being thus the primary means of launching air-to-air missiles towards the target. The radar takes a second to change on to STT mode, and after about 10 seconds the remaining contacts will disappear, leaving only the locked target. In STT submode, manual radar antenna control is inhibited and the B-sweep automatically follows the target. Please note that the target is now getting a lock signal on its RWR. We can unlock the contact, using the switch S2 push or the backspace key. Press spacebar to continue. On STT we get the same target symbology as we did with SAM mode. The HUD target box. The weapon scale. The ASE circle. We also get the same target information on the lower right portion of both the HUD and the radar page. Distance in nautical miles. Time to impact. Closure speed in knots. Target aspect. Now, please place the radar cursor over the HPT and unlock it with S2 press, as we will now study the TWS mode. Good. By unlocking the contact we are now back on the basic RWS screen. Now, please use S2 right to change the radar mode to track while scan, TWS. We will replace the previous contacts with new ones, this time they are at different altitudes, so you can practice the use of the antenna elevation control T6. TWS, Track While Scan, mode. This mode maintains an actual track file on every contact, while still searching for new ones. As with RWS, the radar can handle a maximum of 10 contacts. On TWS the HOTAS S2 switch provides the same functions as on the RWS mode, with the exception that S2 press does not unlock targets, instead it resets the MFCD to their default. Please, do not press it on this tutorial. The display is similar to the RWS, but on TWS each contact has a small vector to denote its heading, in addition to its altitude. Unlike STT, a missile launch on TWS mode will not trigger the enemy's RWR and the first warning the enemy pilot will get is when the missile goes active near its target. We will now review the elements of the TWS display that are different from the already seen RWS mode. Press spacebar to continue. On TWS mode, the azimuth settings are linked to the bar settings, and not as flexible as was the case with RWS. These are the combinations allowed on TWS. Azimuth 10 degrees. 4 bars. Azimuth 25 degrees. 3 bars. Azimuth 60 degrees. 2 bars. Also, on TWS these values can't be cycled on the HOTAS. For this lesson, please set the azimuth to 60 degrees, 2 bars. Press spacebar to continue. On TWS mode, the radar has only 2 PRF settings. High PRF, used to detect targets that are coming toward us. Medium PRF, used to detect targets that are going away from us. There is no auto setting. The highlight shows the current setting and the button next to it allows us to change it. Press spacebar to continue. TWS does not have a SAM submod, but you still can bug one contact and it will be marked as HPT. Once you have located at least 3 contacts, give it a try and bug one of them. Press spacebar once you have an HPT bug. Good, this is very similar to the SAM submod of RWS. We can see that, upon pressing T5, the bug contact is now enclosed within a circle to denote that this is an HPT contact, high priority target. Detailed HPT data is shown on the display corner, distance in nautical miles, time to impact, closure speed and target aspect. Please note that the target does not get a lock signal on its RWR. Press spacebar to continue. On the same way as RWS, on TWS mode we can bug a second contact as SPT, secondary priority target, and then enter onto DTT, dual target tracking, submod. This submode allows you to attack 2 different contacts simultaneously. Let's try it. Move the TDC over one of the remaining contacts, and press T5 a single time. Good, we are now in DTT mode, with both an HPT and an SPT targets shown. The symbol of the SPT is the same as the HPT but without a circle. On the HUD only the HPT gets a target box. If we were now to fire 2 missiles, the first would go towards the HPT and the second goes to the SPT. S2 left will switch between the HPT and SPT, try it. Please note that none of these targets will get a lock signal on their RWR. Now, unlock one of the contacts by placing the cursor over it and using S2 press. Good, by unlocking the contact we are now back on the basic TWS screen. Now, please use S2 left to change the radar mode to velocity search, VS. We will replace the previous contacts with new ones, this time they are at different speeds, so you can appreciate how they show up on the radar display. VS, Velocity Search, mode. This mode is used for long-range detection against target coming at us. It gives velocity and azimuth information, but not range. The vertical display scale shows speed instead of range. Adjust elevation and azimuth until you find some contacts. Press spacebar once you have contacts on the screen. On VS mode, the radar cursor shows a third value. In addition to the altitude range of the radar cone on its right, there is now the contact speed on its left, in tens of knots. A 40 means 400 knots. Press spacebar to continue. The azimuth adjustment is the same as on RWS mode, 15, 30 or 60 degrees, for each half of the radar cone. You can cycle the azimuth values using the HOTAS, sensor control S2 right. For this lesson, please set it to 60. Press spacebar to continue. On VS mode, you have available 3 scan patterns, 1 bar, 2 bar and 4 bar. On the bottom left corner of the display you can see which bar number is currently being scanned. Press spacebar to continue. On VS mode, the radar only uses high PRF to detect target that are coming toward us. Please note that you cannot bug contacts, nor fire weapons, on VS mode. It is strictly a detection mode. Press spacebar to continue. Well done, we are now at the end of this training lesson. The subjects covered during it were: Introduction and radar air-to-air modes, MFCD setup, describe radar modes, RWS mode, SAM, STT and DTT submodes, TWS mode, STT and DTT submodes, VS mode. You may now press escape and leave the mission.